Okay, this is today's question where we were looking at sketching the graph of a cubic equation. Now, I want you to take a look at this one here. The cubic one we tried was f of x equals x times x minus 2 to the second power. Well, this is going to be x times x, which makes it x squared times another x. You know that's a cubic equation. If it was given in this form, it's a really nice form for looking at what makes y equal 0. When y is 0, that is going to give you x-intercepts. So you can just look at it and see that if you put 2 in there, 2 minus 2 makes this bracket 0. And 0 times 2 is 0. So x equals 0 is an x-intercept of this cubic equation. The other thing we've got here is that x equals 2 is going to make it 0, and x equals 0 is going to make it 0. Those are the two things that make it 0. Those are x-intercepts. Actually, the first thing I wanted to do, and I left it out here, is looking at the number in front of x cubed here. If we multiply x minus 2 times x minus 2, we're going to get x squared minus 4x plus 4. And if we multiply everything by x, which we have to, this is called the standard form, x cubed minus 4x squared plus 4x and plus 0. There's nothing added on at the end there. Okay, the first thing to look at is this number in front here. A is 1, is the shape. And this kind of shape is, I kind of call it a happy cubic equation, because it's got two curves, one that goes down, then one that comes up. It ends up going up to the, going up to the nice place. So that's why it's kind of happy. That's the shape of this cubic equation. Now, if you let x equal 0, all of these will be 0, and y equals 0. So that gives us the y-intercept is y equals 0. But x is 0, that's also an x-intercept, but we get the y-intercept by letting x equal 0. Okay, there's the intercepts. We know the shape. Now we need to know these things right at the top and bottom of the curves. We need to know right here and right here the stationary or turning points. So what we do to do that is we have to find the first derivative to find gradients and let it equal 0. We want to find out where the gradient is 0. So, and the first derivative tells us all about gradients. So we find the first derivative. We go 3x squared minus 8x plus 4. There's the derivative, and we let it equal 0. We want to find the x values that'll make it 0. Now, I kind of cheated and used a quadratic formula because I wasn't expecting this to factor. But it does factor kind of nicely. If you use a quadratic formula, you'll get these two answers, 2 over 3 and 2. Well, let's see. 3x times x is 3x squared. 2 times 2 gives me 4, minus 2 times minus 2. But hey, minus 8x and minus 2x give me the minus 6x, and minus 2x give me the minus 8x. So it does factor. 2 over 3 and x equals 2 are your solutions. Now, all you do is take this 2 over 3 and put it back into the original function, every one of those, and let your calculator do the work, and you'll see the answer is 32 over 27, a little bit more than 1, around 1.2. That's the y-coordinate, 32 over 27. And we already know that when we put in 2, we get 0 out for x. That's the other turning point. The last thing is an inflection point. And what we do, an inflection point is about where it changes concavity from concave down to concave up. There's a point where that happens. And what you have to do for concavity is take the second derivative. Just do the derivative again. 2 times 3 is 6x. 1 times minus 8. There it is. If you let the second derivative equal 0, you always get the inflection point. The first derivative 0, we always get turning points. The second derivative 0, you get the inflection point. So we add 8, divide by 6. 8 over 6 is 4 over 3. Then take 4 over 3. That's the x value where the inflection point happens. The y value, we just take 4 over 3, put it back in here, square it, multiply by 4 over 3, and we get 16 over 27. Now, all we do is we take all these things and we sketch a graph. We know it goes through 0 and 0. We know one of the turning points is 2 over 3 and a little bit more than 1.2, which is 32 over 27. We know that 2 and 0, that it turns right there. And we know that the inflection point, where it changes from a hat to a cup here, to concave down to concave up, is right there. So there's our turning points, there's our inflection point, and it's kind of good to notice that when you've got x minus 2 squared like this, it always turns right on that point. It'll turn on the square like that. And there's your sketch. I cheated and used GeoGebra to sketch it perfectly. You just need a neat rough one. And I guess that's about it for today. And I'm